Hi everyone, it's Actuary Dude over here, going to do another CT1 question. So, the force of interest delta t at time t is AT plus BT squared, where A and B are constants. An amount £100 invested at time t equals 0 accumulates to £150 at time t equals 5, and £230 at time t equals 10. So what's A and B? Well, we already know that if we take £100 and we accumulate that using our force of interest, so we're just using the positive integral between 5 and 0 of that function, AT plus BT squared dt, we're going to be given £150. So let's try and simplify this. So we'll just say 100e, and what's the integral of that? Well, that's going to be AT squared on 2, and I'll put that in square brackets, plus BT cubed on 3. Close the square brackets, and that's still between 5 and 0, and it all still equals 150. So then all we do is we just sub in 5 and 0. So we're going to get 100e, and then we put 5 in there, that's going to be 25a on 2, which can be 12.5a, plus, and that's 125 divided by 3b, and so I'll just work out what 125 divided by 3 is, 41.66. So going onwards, times b, minus, when you sub in 0 there, that's all 0, so there's nothing there, equals 150. And let's simplify this a bit further. We'll divide by 100 and then take the natural log of both sides. So 12.5a plus 41.66b equals the natural log of 150 divided by 100 is 1.5. Okay, so that's our first equation. Now let's do it for the other one. So we know that if we have 100 and we accumulate that until for 10 years, and using that same delta t function, dt is equal to £230. So all we do is we'll take the integral of that, so we can really, I'm just going to be rewriting this bit over here, AT squared on 2 plus BT cubed on 3, in between 10 and 0, equals 230. Now when we sub 10 into this bit over here, we're still going to be getting 100, 100 in there, so 10 squared divided by 2 is 50, a plus 10 cubed is 1000 divided by 3 is 333.33 b, and then when we sub 0 in there, that's going to be 0 plus 0, and so all of this minus 0 is the same thing, equals 230. And so now to just simplify it, so our next equation will be, if we just divide everything by 100 and take the natural log, 50a plus 333.33b is equal to the natural log of 230 divided by 100, and 230 divided by 100 is 2.3, so the natural log of 2.3, and that's our second equation. So now we just need to solve for a and b. How do we do that? Okay, I'm just going to try to eliminate one of the equations. So if I can find, well, not one of the equations, one of the variables. So 12.5, if I actually times that by 4, that'll get to 50a. So let's multiply everything in equation 1. So that should be 50a plus, what is that number, 41.66 times 4? It's 166.66. B is equal to 4ln 1.5, and that can be our equation 3. And so now let's just do equation 2 minus equation 3. So the 50a's will cancel out. 333b minus 166.66b. I imagine that's going to be the same thing, minus that number there. Yeah, 166.66. So 0.66b is equal to ln 2.3 minus 4ln 1.5. So let's find out what that is. ln 2.3 minus 4ln 1.5. There we go, negative 0.7889. That was 889, and there was a 5 there. And so b is equal to this divided by the 166.66. So equals that divided by, there we go, negative 0.0047337. what was that, 4, and I think it was 7337. Is that about right? Yep, that was right. Okay, so that's what B is, and now we just sub that in to find out what A is equal to. So let's just use our first equation then. So here we have B times that 41 bit. So that's B times, this is what, sorry, not 41, there we go, times 41. And then it was the natural log, so equals ln 1.5 minus that number, and then divide everything by 12.5. And that's what A is equal to, 0.04821624. 0.0482, was it 164, I think, if I remember. Yep, that's right, so that's what A is equal to. Okay, hard part done, that's most of the marks. Now let's find out the next bit. Calculate the constant force of interest that would give rise to the same accumulation value from time 0 to time t equals 10. So it's saying over here that if we start with 100, e to what rate of interest, force of interest, sorry, 10 years, it's going to be equal to 230 pounds there. So all that's going to be is divide everything by 100, take the natural log. So then delta 10 is equal to ln 2.3, because 230 divided by 100 is 2.3, and then we can just divide everything by 10. So if I just went like that, cancel that bit out. So what is delta equal to? Let's look at that. Equals ln 2.3 all divided by 10. Here we go. 8.32991%. So that was 0.08329091. Okay, so that's part 2. And lastly, part 3 is saying, what did it ask for? The force of interest calculated in that, so assuming we got this right, calculate the present value of a continuous payment stream, which is this, 20e.05t, paid from 0 to time 10. So 20e.05t. Okay. T, and that's got to be between time 10 and time 0, and this is how you calculate the present value. You take the integral of the rate multiplied by v of t, and in this case, v of t is going to be e to the negative integral of delta t, and the integral of this between time t and time 0 is going to be 0.08329091 t dt. Okay, so how do we find this? Very easy, let's simplify things. So let's take out 20, keep the integral bit there. That's a positive 0.05 and that's a minus 0.08, so it's still going to be e to the negative 0.03299091 t dt in between 10 and 0. So now that we've got that, we've just got to find the integral of that. The integral of this is the same function divided by the derivative of the index up here. So that's going to be 20. I can actually divide it all. I can take that bit out, say minus 0.032 and so on. And then I'll just write it so it's a little clearer. And then I can already take out and say e to the negative, that bit goes in between time 10 and time 0. And that should give us our answer once we use our calculator for this. So I'm just going to use this part over here and find the first term. So that is 20 divided by negative 0.0329091. So that's what we've got over there. Just making sure that I did this all right. Sorry, it's close to it. That's 0.083, so it's going to be 332 over there. 332. Yeah, there we go. So that's actually then a 3 in here, like that, and that's a 3 and then a 2. Okay, so let's go back to Excel. There's that bit, and now we're going to find the exponential of negative 0.033. Sorry, I'll just drag that across. 3329091 multiplied by 10 minus the exponential of that same thing, negative 0.033 0.32991 times by 0 is then going to be equal to that bit, and then when we multiply them together, there we have 170.11 or 0.12 pounds, 170.12. And that's the answer to part 3 of the questions. Thanks for watching. If you've got any questions, then please ask me.